Hey class, here is the video for the Unit 5 review for the test, okay? So the first question says here, look at the system of equations. What is the x value of the solution? So remember that the solutions to a system of equations is where these two lines cross each other. So I'm just going to do this in Desmos. I taught you guys 3 different ways to solve system of equation. Substitution, elimination, and then graphing. Graphing is going to be the easiest, okay? So we're just going to graph this equation, 3x minus 5y equals 15. And then the other one, y equals 2x plus 4. And then you're just going to go on the graph and check where they cross each other. They cross at this point, -5, -6. Remember, the solution is going to be -5, -6. Remember that on the coordinate plane, we write the x coordinate first and then the y coordinate. Because it's asking you for the x, that means it's going to be -5. And that's that. It says here, look at the system of equations. So I have 2 equations. Which ordered pair is a solution to the system? So same thing, we're just going to graph it. But we do have some fractions and decimals here, so we have to be careful to find our answer. But it's easy. Just plug it in Desmos. You will have access to Desmos on the test. So plug it in. And then on this one, just be careful because sometimes if you zoom out and you click and you have all of these points, it's best to zoom in to where the solution will be, which is right here. Okay, and that's it. That's our solution. Let me write it down and then I will try to find it here. So my solution is 2.75 and then 0.25. It's going to be A because you have the fractions, but it's good to always, in case your test question has different answer choices and you have more than 1 fractions or decimals, just check it in Desmos. 11/4 is equal to 7.5, which is what I have here. And then 1/4 is 0.25, which is what I have here. Okay, so it is definitely A. All right, and then you're going to have this word problem. It says here, a large group of 30 people attended a soccer game. Each person ordered a hot dog or a slice of pizza. Each hot dog cost $3.50, and each slice of pizza cost $5.25. The total bill was $88.50. So there's 2 equations here, okay? Remember that whenever you're building your system of equations, you have either the first equation, you'll have the quantity, and then the second equation, you'll have the money part, okay? So you're just putting the different things together. It says here, let x represent the number of hot dogs. So the number of hot dogs is x. Where do I write that? I don't know. Well, it's x. Okay, I'll just write it here, x. And then let y represent the number of slices of pizza. So pizza is y. And then remember that each person got a hot dog or a slice of pizza. So a hot dog plus slices of pizza. And how many people were there? There were 30 people. So together, I don't know how many that were sold of hot dogs or pizza, but I do know that together they sold it to 30 people. So that's my first equation. And then also, each hot dog costs $3.50. So the money part is $3.50 per hot dog, so times x, plus $5.25 for the pizza, so y. And together they spent the bill was $88.50. Okay, I don't know why I wrote it up there. It should be written down here. Anyway, these are my 2 equations. So I'll just move it up here. There's my system of equations. The first one was the the amount of pizzas and hot dogs that we bought, like how many. And then the second equation was the money part, like how much did it all cost together. So you have to just put each together. Anyway, this one is just asking you to find the equations. So the first equation and then the last equation. So these two equations are what it is. Even though it's not asking me, I do want to just kind of finish this problem. I'm curious, how many hot dogs and how many pizzas? Let's check. So it's just a system of equation. I don't have to put the 0. It doesn't really matter. Okay. We're going to press home. Search for your answer. That didn't really work out because it's saying that it's 39. What did I do wrong? Oh, okay. Forget about the answer part. The numbers, we just pick some numbers. 30. I don't know, something's not adding up. But the equations that we chose are true, are good. Okay, the way we set it up is good. Okay, so let's just leave it at that. All right, next question. It says here, directions. Type your answer in the box below. Enter the answer only. Use only numbers. Okay. Do not use letters. All right. So here's where the actual question starts. A system of linear equations has infinitely many solutions. One equation is 25x minus 5y equals 10. Fill in the blank to create the other equation to the system. So basically, we just have to put a number here. Now, when it says infinitely many solutions, we know that what the graph should look like. Okay. Actually, let's go ahead and do number 5 real quick, and then it'll help us to see what the graph for infinitely many solutions should always look like. Okay. So one solution, the graph will look like this, where you have two separate lines and then they're crossing somewhere. Okay. So this goes here. This graph goes here. On the test, you'll be able to move these graphs in different spots. No solution is when you have a pair of parallel lines, okay? So that would what a no solution would look like. And then the infinitely many solutions is what I'm interested for to help us with problem number 4, is when you graph the two lines, they end up being the same graph. Basically, they're the same equation, okay? So in Desmos, what I'm going to do is, I know that I'm already given one equation, so I'm going to go ahead and type that in. 25x plus negative 5y equals 10. Negative 5y equals 10. Okay, I'm just always like to press the home button just to see it. So there's my graph, okay? So whatever number I put here has to be the same as this graph. So, I mean, if you want to, you can just like guess some numbers. You don't have to guess, but there is another way to do this, but I don't know. You just want to be done with this, right? So you can just guess some numbers. 2. See, when I put a 2 there in front of the x, it didn't give me the same graph as the purple graph. So maybe it's -2. No, negative just makes it go the other way. So it has to be a positive number. 3. Oh, it's getting closer. 4. Very closer. It's got to be 5. There you go. 5 works. Okay. So this number in here is 5. You're going to type that in. So that's how I would do this problem. For those of you who are like, Ms. Akula, there has to be another way instead of just guessing. There has to be a mathematical way. Yes, there is. Well, you know that the reason that these two have the same graph is because they're the same equation. And this equation is solve for y, right? So what I could do here is just solve this equation for y and see what it equals to. I'll do it real quick. It just takes like 2 seconds. So to solve for y, I'll go ahead and take the x term over. We're basically putting it in slope-intercept form. They're not like terms. I'm not subtracting or adding or whatever those two numbers. I'm just rewriting it. So negative 25x, positive 10. So I have to put plus 10 here. And then divide by negative 5 throughout. All right, so you have y equals negative 25 divided by 5 is positive 5x. 10 divided by negative 5 is negative 2. See, the negative 2 is here, and then here's where your 5 is. Okay, so that's that. Part B for number 5 is not on the test, but I like this problem, so I kept it in my review. This problem was on the test last year, but I'll just show you. It says here, Miriam wants to solve a system of equation by graphing. Her graph is shown below. So this is what she gets. Based on her graph, she can conclude that the system has one solution. A lot of students were saying this is no solutions because the graphs don't cross, but the arrows mean that if you zoom out, the lines keep extending. They just keep going. But as they keep going, look, they will cross at some point. Okay. The only way that it's a no solution is if you have parallel lines. Okay, but anyway, clearly they're not parallel lines. They have two different directions. That's that. All right, number 6. Graph it and then just match the graph. Okay, just be very careful. Don't pick the graph that it kind of looks like. Pick the graph that it exactly looks like. Okay, so right here, I picked B. It is exactly that. The slopes look the same. The graphing is graphed to up. And then also, just check. Look, it goes through 1, 2, 3. This one also goes through 3. And then it kind of goes through like negative 1.5, negative 1. Yeah, everything matches up. Oh, and also, it's a solid line. Okay, so for example, if I... it's not on here, but if I put like that, then that would be a dotted line, but the graph is showing a solid line. So be careful of that. Okay. All right. Anyway, it's B. Sorry, I don't want this video to be too long. All right, and then same thing for 7. We're just going to graph the system, but be very careful here because the graph to a linear system of inequalities looks like this. The solutions is not everything that's shaded, right? So it's not everything that's shaded. It's only the part where they're overlapping. So the green graph plus the purple graph mixed together is my solution. Okay, so that's that. So it's going to be C, this area right here. All right, number 8. Lisa is planning a vacation to Disneyland. I love Disneyland, y'all. I went there for the first time this summer and I want to go. Anyway, Disneyland and Universal Studios. She wants to stay at least 9 days. Okay. The cost is $250 per day at Disneyland. That's expensive. I forgot how expensive it was. Kind of expensive. The cost is $300 per day for Universal Studios. She will not spend more than $3,500, and she wants to stay X days in Disneyland and Y days in Universal Studios. So again, you have the number of days in the first equation, the number part, and then the cost in the second equation, the money part. Well, the number of Disney days she stays and the number of Universal Studios together, she wants to stay at least 9 days, meaning that she wants to stay more than 9 days, at least 9 days. Okay, she doesn't want to stay less than 9 days. So she wants to stay more than 9 days or equal to. Whenever you have word problems, by default, just put equal to. It will be very specific when it says, when you don't want it to be equal to. It'll say, but not more, not exactly 9 days or something like that. Okay. So anyway, at least means that she wants to stay a minimum of 9 days or more. Okay. Good, Lisa. You should stay more than 9 days. Anyway, and then the money part, she doesn't want to spend that much money, right? She doesn't want to spend more than this. So whatever she spends has to be less than or equal to 3,500. Okay, you just have to pick the right inequalities. All right, number 9. I did this problem in class, but I'll just just a little mistake that I made. A little typo here. This should say 40 classes. Excuse me. This should say 40 classes. And this should also say 40 classes. All right. So direction. Select all the correct answers. Well, I want to select all the correct answers so I can get a good grade. All right. Peter wants to take art classes at an art club. That sounds fun. All right. With membership, there is a fee of $300 and a cost of $9.50 per class. With non-membership, no membership, it costs $15 for each, $15.50 each class. Okay? So Peter graphs the system. I mean, who doesn't graph the system of education when they're faced with this problem? So the first equation is you start at 300 and then per each class, so this is the number of classes, it's going to keep going up. So you take one class, it goes up plus 950, another 950, another 950 or so. So you have a linear equation. So this is your membership. That's with membership. If you have to pay 300 first, and then you take your classes at a lower cost. And then no membership, you don't have to pay anything at first. And then per class, it costs a little bit more, 1550. So 1550, 1550 per class, and it keeps going up. So that's the situation that I have here. These are my equations. All right, so let's pick two correct things here. It says that the cost of membership and non-membership is the same for 50 classes. So at 50 classes, the non-membership pays $775, and then the other for membership also pays $775. So that is true. Okay, the 775 comes from the y-axis, right? So this is at 775 right here. I could graph it in Desmos and find it as well, but right here. Okay. It's a cost that much money. The cost of membership and non-membership is the same for 775 classes. No, the 775 classes will be like a lot, and then it's not. They're already met here, so they're gonna just keep going up away from each other. So it's gonna be different prices after this. This is the only time when they're the same price. Okay, so this is not true. So if he takes 40 classes, it costs less to get a membership, or if he takes 40 classes, it costs less for a non-membership. All right, so let's see here. Let me pick a different color. So 40 classes is right here. So let's see where they meet. So here's where it is for non-members, and then here's where it is for members right here. Obviously, it costs less for non-members, right? Non-members is about $610 or so, and then for members, it costs about $690 or so. So definitely costs less for a non-membership for 50 classes. It costs less for non-member. No, that's, what am I doing? Costs less for non-membership. So this is the answer. Okay. Let me know if you have any questions about this in class, how I got these answers. All right, y'all, one more question. So let's take a look at this graph. I'm going to go ahead and graph it in Desmos. So here's the first equation. Y plus 2x is less than or equal to 5. And then y greater than 1 over 4x minus 4. All right, press the home button. All right, so system of equations, remember, is where the red graph and then the gray graph, they're meeting. Okay, so they're over here. So I can't really write on here, but I can type on here. Here, let me go ahead and put all of my points, and then we'll take a look at them, look at each one. Okay, so here's 4, -3. As I'm graphing it, maybe you can find it on there and just look. So here's the first one. Is that a solution? The answer is no, because it's on a dotted line. It has to be like on a solid line. Both of them has to be a solid line. No, no, on a dotted line. Okay, so that's that for that. All right, and then the second point is at 5, 0. You have to pretty much do all of them. The answer to this is no, because it has to be over here, or it could be on the solid line only over here. Okay, so this is also a no. 0, 0 is right here. This is a yes. That is a yes. Okay, so I'll go ahead and mark that on here. I don't want to go back and do it again. Okay. All right. 3, -1. Yes, for this one, because it's on the double shaded part right here, and it's on a solid line. So that one works. Yep. Okay. 2 more. Where is it? Oh, it's right here. No, because it's on a dotted line. Okay. And then the last one, 2, -5. Nope, because it's not in the double shaded part. It's right here. This is also a no. Okay. There you go. That's it. That's the review for the test. And the whole test, like, how long did it take me? About 20 minutes to do. So, yeah. Thanks, guys.